Hello everyone. So we start with another new chapter this week. This is chapter 11 and we are going to talk about local area network in detail in this chapter. Alright, so talking about local area network. Local area, now we will discuss in this chapter about local area network. Local area network are called as LANs. Wide area networks may be public or private, but local area networks are usually owned by the organization that is using the network to interconnect the equipment. So for example, in our college we have the local area network, and that network is owned by the JUC. Local area networks have much greater capacity than the wide area networks to carry what is generally a greater internal communication is needed. And the key elements which are required for the local area network are topology, transmission medium, wiring layout, and medium access control. So together these elements determine not only the cost and capacity of the LAN, but also the type of data that may be transmitted, speed and efficiency of the communication, and even the kinds of applications that can be supported. So let's start our discussion, more discussion on the local area networks. This is a typical diagram of internet, what we require. For example, we have many devices like router, firewall, core switch, distribution switches, edges. Then we have wireless controller, IP telephony. We are going to talk about some of these devices also in this chapter. Alright, going ahead. So let's start our discussion. Let's start our discussion with the local area networks. So the first thing that comes to our mind when we talk about local area network is the word topology or topology. Topology means the way our systems are connected to each other, that is called as the topology, how they are connected. So it refers to the way in which the endpoints or the stations or the user systems, they are attached to the network or they are interconnected. So this is called as the topology. Now, common topology for the LAN there are four common topologies for the LAN, which are bus, tree, ring, and star. These are the four type of topologies. Now, in contemporary LANs, the star topology is based around the use of switches and it dominates. So in contemporary LAN, star topology dominates, but it is also useful to briefly look at the operation of the bus topology because it shares some characteristics with the wireless LANs, and the key elements of the wireless LAN access protocol have evolved from the bus LAN protocol. So in this chapter, first of all, we are going to look at the operation of the different topologies. We are going to talk about the different topologies. Alright, so the four basic types of topologies are, these are bus topology, ring topology, tree topology, and the star topology. Now if you see, in case of the bus topology, you have a single wire going and all the stations, they are attached to that single wire. Whereas in case of ring, the interconnection is forming a ring-like structure or a circle-like structure. In case of a tree, it is forming a tree-like structure with the branches. And in case of a star, you have a central element and the stations are attached to it. So similar to a star-like structure. Alright, now first of all we are going to discuss about bus topology. What is a bus topology? Alright, now in case of bus topology, all the stations, they are attached to the appropriate hardware interfacing known as tap directly to the linear transmission medium or a bus. Now if you see over here all the stations, they are attached to a hardware interfacing known as tap, which is the linear transmission medium. So this is the transmission medium. This medium, this wire is called as bus. So this is the main medium, and to this wire the stations are attached with the help of a tap. Now tap is something, a connection point which will attach our system to the main bus. Full duplex operation between the station and the tap allows data to be transmitted on the bus, and the transmission from any station propagates the length of the medium. Right? Now, how the data will be transmitted on the bus, let's understand it. So, in this example, how the frame will be sent. Suppose system C wants to send data or a frame to system A. So now when it wants to send, it will make a frame out of it, and the header of the frame will include the address of the system A. Now then it will send. Now as the frame travels on this wire, when the frame travels on this wire, first of all it passes through B. Now B checks the address. B checks that does the address on the frame matches with its own address. It will check, no, this address does not match with the address of the B. So what B will do? B will ignore it. Next the frame passes to the A. So now A will check what is the address in the header of the frame and match with its own address. Now when the address is matches, so what A will do? A will copy the frame. A will copy the frame. So A on the other hand sees that the frame is addressed to itself, so it will copy the data from the frame as it goes by. So with bus or tree, no special action has to be taken to remove the frame from the medium. When the signal reaches the end of the medium, it is absorbed by the terminator. So there is no special action needed to remove the frame from the medium. So it can be absorbed by the terminator. So this is how the bus transmission works. Similarly, if A wants to send data to C, now when A will make a frame out of it, the address of the C will be placed on the frame. So similarly, when the frame travels over here, it can be a full duplex bus. When the frame travels over here, it reaches B. B will again check the address. Since the address doesn't match, B will ignore it. When the frame reaches C, C will match the address. Since the address matches to the C's address, so it will copy the frame. It will copy the frame and check the data. All right. So let's understand some of the differences between a bus and the tree. Tree is just like a bus, but what are the differences? Now first of all, let's understand for the bus, what is a bus basically. For the bus, all the stations, they attach through the appropriate hardware. As I told, interfacing, that interfacing is called as a tap, and directly to the linear transmission medium. And full duplex operation between a station and the tap allows the data to be transmitted. So full duplex operation is allowed. The transmission propagates throughout the medium. So the transmission, a signal which is transmitted. So a transmission from any station, a signal which is transmitted from any station, it propagates the length of the medium in both directions, and it can be received by all the other stations. And at the end of the bus, there is a terminator, and the purpose of the terminator is it absorbs any signal which was propagating on the bus and removes that signal from the bus. So this is how the bus works. Now coming to the tree. Tree is a generalization of the bus topology. Let's go back and check what is a tree topology. So if you see, even in the tree, there is a single medium propagating over here. Now these are called as taps. Alright, these are called as the terminators, sorry. These are called as the terminators, and the stations are attached to the wire. Now here there will be some hardware which is called as taps. This is called as the terminator. Now in case of tree topology, again if you see, you have the terminators over here, and a bus will be attached to the main bus. A bus is attached to the main bus, and the systems can be connected either to the main bus or to the other bus which is propagating. So a tree topology is a generalization of the bus topology. The transmission medium is a branching cable with no closed loop. So if you see, the transmission medium is a branching cable and there are no closed loops. The tree layout begins at a point called as the head end. So the tree layout begins at a point, for example from here, this point is called as the head end. Then we have one or more cables which start at the head end, and each of these may have branches. So there can be one or more cables which can start at the head end, and there can be each of these may have branches also. The branches in turn may have additional branches. For example, if this is a branch, this branch can have additional branch, this branch can have additional branch, to allow quite complex layout. Again, a transmission from any station propagates throughout the medium and can be received by all other stations. So the basic working of the tree topology is same as the bus topology, but in terms of layout it is more complex than the bus layout. Alright, so branching cable with no closed loops, tree layout begins at head end and branches out, and same thing, the transmission is heard by all the stations, but the frame will be accepted by the station for which it is intended for, and the other stations will ignore that frame. Alright, now let's move on to the next topology. Alright, so the next topology we are going to talk about is the ring topology. So a ring topology. If you see, ring topology is a closed loop of repeaters joined by point-to-point links. It just forms like a circle or a link. So if you see, there are point-to-point links. This system is connected to this system. This system is connected to this system. So it forms a closed loop or a closed circle-like figure and having the point-to-point link. So in a ring topology, the network consists of a set of repeaters. Repeaters are the hardware devices which are used for increasing the signal of the signal which travels on the wire. We have discussed about it when we were doing the transmission medium. So repeaters joined by point-to-point links in the closed loop. The repeater is comparatively a simple device capable of receiving data on one link, and it allows the data to be transmitted on the bus, and it allows the data to retransmit on the other end. And the links in this are all the unidirectional. Stations are attached to the repeaters. A very important point to note over here is the links are unidirectional. That means, for example, if it is a ring, if it is designed to work in it is designed to work either in a clockwise direction or in a anti-clockwise direction. So the links are unidirectional, which means that data is transmitted only in one direction, so that the data can circulate around the ring in one direction. Either it can be clockwise or it can be anti-clockwise, and all the stations are attached to the repeater. Each station attaches to the network at a repeater, and it can transmit data onto the network with the help of the repeater. Just like the bus and the tree, data are transmitted with the help of the frames. So now in this case, when the frame circulates, it passes through all other stations which are attached on the ring network. The destination station or the system recognizes the address and it copies the frame into the local buffer. The frame then continues to circulate until it returns to the source, whereas in case of bus, When it goes to the terminator, that signal is absorbed. So the source station will remove that frame. Because multiple stations share the ring, medium access control is needed to determine what time each station may insert at the frame. So these are some of the points for the ring. First thing is, it forms a closed loop like structures. It can receive data on one link and retransmit on another. It's a unidirectional, so it can work only in one direction, either clockwise or anti-clockwise. Alright, now for example, let's see over here. For example, this is a ring network. This is an example of the ring network over here. Now in this, if you see, station C is trying to transmit a frame to data A. The frame header includes the address of system A. Now as the frame circulates, when the frame circulates around the ring, it passes through B. So what B will do, a frame is not addressed to B. So what B will do, B observes that the address is not the station of B, so it ignores the frame A. On the other hand, when it goes to the C, C sees that the frame is addressed to itself, and therefore it copies the data from the frame as it goes by. So if you see over here, frame is not addressed to B, B ignores it. C copies the frame, A copies the frame because C is sending, so A copies the frame when it goes by, and at this point when it reaches the C, C absorbs the returning frame. So in case of bus network, it was the terminator which was absorbing the frame, whereas in case of a ring network, it is the source station which should absorb the frame. Now let's talk about one more topology, which is the ring topology, star topology. Alright, so here we have the star topology. Now in case of star topology, each station connects to a common central node, and that common central node is called as a hub. All the stations attached to the common central node, and that common central station is called as the hub. Usually it is attached via two point-to-point links. One is for sending, another one is for receiving. So there are two separate point-to-point links. One is for transmission and another one is for reception. The central node, which is the hub, it operates in a broadcast fashion. Broadcast means, so when a data is sent, it will be received by all the stations attached to it. It can be so there can be actually two alternatives for operating the central node. So first approach is in the broadcast fashion. So in this case, what will happen when a frame is transmitted from one station to the node, it is transmitted on all outgoing links. So in this case, although the arrangement is physically a star, it is just like logically a bus. So a transmission from any station is received by all the stations which are attached, but only one station at a time will can successfully transmit. So in this case, the central element is called as the the central element is called as the hub. But another approach for the central node is to act as a frame switching device. So when it acts like a hub, that means it transmits in a broadcast fashion. When the frame is sent from one station to the another, it is sent to all the stations, and only one station can transmit at a time. But it can also act like a frame. Frame switching device. So in that case, incoming frame is buffered in the node and then transmitted on the outgoing link to the destination station. So these approaches, these are the two approaches in which a hub can work for the star topology. Alright, so let's talk about The choice of topology, whatever the topology, we may choose any kind of topology when we are thinking about the LAN or when we are designing a LAN, but the choice of the topology depends upon three factors. First one is reliability. So we need to think how reliable my LAN will be if I choose a particular kind of topology. Second thing is performance, how well it will perform under the certain given conditions. And expandability. Expandability means suppose at present I have only 10 users or 10 systems. Later on in the future, if I have more employees or more systems need to be attached, how easily I can expand my topology. So these are the factors which are considered while we are choosing a particular kind of topology. Alright, now let's talk about what kind of medium can be used for designing various kind of topologies. There are four alternative media that can be used in bus LAN. So, first is twisted pair, and there are two kind of topologies. Two kind of medium, a twisted pair and the baseband coaxial cable. So twisted pair, in the early days of LAN development, voice grade twisted pair was used to provide an inexpensive and easily installed bus LAN. A number of systems operating at a speed of 1 megabits per second were implemented, and scaling up for higher data rates was not practical, so this approach was dropped long ago, that means using the twisted pair. Next is baseband coaxial cable. It uses a digital signaling, and original Ethernet makes use of the baseband coaxial cable. We have actually two types of transmission, baseband and broadband transmission. In baseband transmission, whole bandwidth of the cable is utilized by the single signal, and using the baseband transmission it is possible to transmit multiple signals on a single cable, and by using a process called as the multiplexing, and the baseband transmission uses the time division multiplexing. Whereas in case of broadband transmission, multiple signals are sent on multiple frequencies simultaneously using single channel, and multiple channels can be created in a broadband system by using a multiplexing technique which is called as the frequency multiplexing. So these are the type of the cables which we can use in the bus topology. These were the two types. Now we have next two types also. Broadband coaxial cable. Now broadband coaxial cable. So broadband coaxial cable is a type of cable which was used in the television systems. Analog signaling is used at radio and television frequencies, and this type of system is more expensive and difficult to install, because we know that coaxial cables are difficult to install and maintain than the baseband coaxial cable. So this approach never achieved popularity, and such LANs are no longer made. So that means twisted pair cables had a problem. It has been dropped long ago. It is currently used. Original Ethernet made use of baseband coaxial cables, and broadband coaxial cables, they were used only in the cable TV systems, but it is expensive and hard to install. So again, it is not that much popular. Last one is the fiber optic cable. There has been considerable research related to this alternative over the years, but the expense of optical fiber taps, that means the connectors, and the availability of better alternatives, it has resulted in a demise of this option as well. So thus, for a bus topology, only baseband coaxial cable has achieved a widespread use. So coaxial cable, baseband coaxial cable is used more popularly. Alright, now coming to the ring and the star topology. Ring and star topology, they need very high speed links, and they can transmit over long distances, and they have potential of providing best throughput. However, single link or repeater failure disables the network, because in case of ring, if I go back, for example, if this wire fails, if this link fails, what will happen? My whole network will stop, because in this case, for example, if my network is designed to work like this way, so this system will be cut off, system will be cut off from all the other systems. Similarly, these two cannot transmit to each other. So failure of a single transmission link can hamper my transmission. Alright. So single link or a repeater failure disables the network. Star network, it uses the natural layout for wiring in a building. It is best for short distances and it has higher rates for small number of devices. Alright, so moving ahead. Alright, choice of a medium. So when we are choosing a medium for a particular LAN topology, choice of a medium is constrained by whatever topology we are choosing. So we need to check these factors. First one is the capacity, reliability, types of data supported, and environmental scope. So these are the four factors which govern the choice of the topology. Capacity means to support the expected network traffic. There can be huge amount of traffic, so whatever the cable we choose, it should be able to support the network traffic which can be expected on that particular route. Then reliability, and the medium should be reliable. That means it should be available all the time. Whenever the user wants to send the data, it should not be like the cable is down or there are problems in the transmission link. No. Types of data supported. What type of data it can transmit, whether digital data or analog data or what type of data. Environmental scope, provides service over the range of the environment. So over the range of environments, it can provide multiple types of services. So these are the four factors which govern the choice of medium. Alright, now what are the types of medium available in the market? So we have voice grade unshielded twisted pair, which is UTP. It is used in category 3 phones, it has cheap and low data rates. Then we have shielded twisted pair baseband coaxial cable. It is more expensive but it has higher data rates. We have a broadband cable. It is more expensive than the baseband coaxial cables but it has higher data rates. We have high performance UTP cable, which is category 5 and upwards. It has very higher data rate. It is suited for the star topology. And the last one is optical fiber. It is secure, it has high capacity, it is small in size, but again it is very, very costly. Alright, now we will talk about certain devices which we can use on the LAN. And the first device which is quite important device is the bridge. So let's first talk about bridges, a very important device. The purpose of the bridge is to connect similar type of LAN. So basically the bridge connects LANs together. It can connect number of LANs together. So in almost all the cases we need to expand our local area network. And there are two general approaches which can be used to expand our local area network. One can be with the help of the bridges, another one can be with the help of the router. So first of all, let's talk about the bridges over here. A bridge is the simpler device out of router and bridge. Bridge is the simpler device and it helps to interconnect similar LANs. So it connects similar LANs with identical physical and link layer protocols. Whereas a router is a more general purpose device. It is capable of connecting. A router can connect LANs as well as wide area networks. Whereas bridge is a device which is used to connect only for the local area networks. So we will talk about bridges in this section. The bridge is designed to use between local area network that use identical protocol for the physical layer and the data link layer. Because all the devices, they use the same protocol, so the amount of processing required at the bridge is minimal. So amount of processing the information or sending the frame is minimal. More sophisticated bridges are capable of mapping from one MAC format to the another MAC format. So more advanced bridges, they can map between the different types of MAC formats. Now, why do we use a bridge? Because bridge is used in a situation in which all local area networks, they have the same characteristics. So you may have a question that why not simply to have one large local area network, why to use a bridge? So there are several reasons to use a bridge to connect multiple LANs together, and the first reason to use a bridge is reliability. So the danger in connecting all data processing device in an organization to one network is that if there is a fault on the network, it may disable communication, it may disrupt the communication for all the devices. So that means all your network can be down. So if we use a bridge, only a part of network can be down, the other part is still working. So by using a bridge, the network can be partitioned into self-contained units. So if there can be a fault only at one LAN, but the other LAN will still be working. So one reason to use bridge is reliability. Second reason to use a bridge is the performance. So the performance on a LAN declines. So the performance or the speed will decline when we have more number of devices on the local area network. So if we divide our large LAN into number of smaller LANs, it will give us a good speed and improved performance. So if devices can be clustered, internet traffic will significantly exceed the internet traffic. Third reason is the security. If we establish multiple LANs, it may improve the security of the communication. So it is desirable to keep different types of traffic. For example, accounting, personal, or security that have different security needs on a physical separate media. So that is also one of the reasons. Last one is the geography. So the two separate LANs are needed to support devices. They are clustered into two geographical distant locations. Even in case of two buildings separated by a highway, it may be easier to use a microwave bridge than to use a string coaxial cable to have between the two buildings. So these are some of the advantages or the reasons of using a LAN. Now bridge functionality. Now let's understand how this bridge is working, how we have used a bridge. So we have two local area networks. Actually we have 20 users in our network. So instead of having only one network having 20 users, what we have done, we have divided our network into local area network into two networks. One is local area network A and another one is local area network B. And how we have divided? We have used a bridge. So on local area network we have 10 stations and local area network B we have 10 stations. So if you see now, bandwidth, whatever the bandwidth was shared by 20 systems before, it has been divided. So the communication will be faster now. So this actually, this is the bridge which has divided the LAN into two LANs. But the LAN A contains users 1 to 10 or the stations 1 to 10, and the LAN B contains stations 11 to 20. Alright, so in this case, let's understand the action of a bridge which is connecting two LANs A and B, and we assume that both the LANs, they use the same MAC protocol. So in this case, this single bridge is attached to both the LANs, and frequently the bridge function is performed by two half bridges on each LAN. So the function of the bridge is simple. Now what it will do, it will read all the frames transmitted on A and accept those addressed to any station on station B. So whatever the frames are transmitted on station A, for example, if one wants to transmit to station 2 or wants to transmit to station 3, it will accept, it will read all the frames which are transmitted on local area network and it will accept those frames which are to be transmitted to any station on B. So suppose, for example, station 1 wants to transmit a frame to station 12. So it will accept that frame which needs to be transmitted to any station on the local area network B. So it will accept. So the bridge will accept that frame. Using the medium access protocol for B, it will retransmit each frame on B. So it will use the MAC protocol and then it will retransmit for B. And it will do the same thing for B to A traffic. For example, it will read all the frames which are transmitted on local area network B. So for example, if 11 wants to transmit a frame to station 20, so it will read all the frames which are transmitted on LAN A. Now for example, station 12 wants to transmit a frame to station 2. So it will accept this frame which is intended for local area network, and after accepting it, what it will do, using the MAC protocol for LAN A, it will retransmit each frame on A, and this is how the bridge will function. Alright, now let's talk about the bridge design aspects. Several design aspects of bridge can be there. Alright, so first thing is bridge makes no modification to the frame content or format. So bridge should make no modification to the content or format of the frame it receives, nor it should encapsulate them with some additional header. This is what is required. So it should not alter the contents of the frame or whatever data it receives, and moreover it should not encapsulate with an additional header. Each frame can be transferred, each frame to be transferred is simply copied from one LAN and repeated with exactly the same bit pattern on the other LAN. Because two LANs, they use the same LAN protocols, it is allowed to do it. Second thing is, bridge should contain enough buffer space to meet the peak demand. So buffering should be there because frames may arrive faster than they can be transmitted. Over a short period of time, frames may arrive faster. Third thing is, bridge must contain addressing and routing intelligence. Going ahead, let me check if it must contain routing and addressing intelligence. So at a minimum, the bridge should know which addresses are on which network to know which frames to pass. Further, there should be more than two LANs if there are more than two LANs interconnected by number of bridges. So in that case, frames may have to be routed through several bridges in its journey from source to the destination. Then bridges may connect more than two LANs. So bridging is transparent to all the stations. So each station has a unique address and does not need explicitly to discriminate between the stations on the same LAN or stations on the other LAN. So for example, what does this mean? If a station wants to transmit a frame to any of the station, it should not explicitly tell the bridge that this station lies on LAN B or LAN X or LAN Y or whatever. Or the bridge should take care of that. So in short, what I can say, the bridge provides an extension to the local area network that requires no modification to the frames that are being communicated to the stations on the local area network. So it appears to all the stations on the LAN that there is a single LAN. So what does this mean? This means that if a station 1 is sending a frame to station 2 or to station 20, it should appear to the station that it is transmitting a frame on a single LAN, and on which each station has a unique address. The station uses that unique address and need not to explicitly discriminate between the stations on the same LAN. So what does this mean? This means that when a station 1 wants to send data to station 2 or 20, it should not specify that station 20 lies on local area network B and station 2 lies on LAN A. It is the responsibility of the bridge to check which station lies on which LAN. So for the stations, it should appear that it is on a single LAN. Now let's talk about the bridge protocol architecture. What are the tasks? Bridge captures the frame, encapsulates it, forwards it across the link, it removes encapsulation, and then it transmits to the destination. So this is what a bridge is expected to do. So how the LANs are connected to each other with the help of the bridge, let's look at this. Now this figure shows the simplest case in which two LANs can be connected to each other with the help of a single bridge. The LANs employ same MAC and the same LLC protocol. LLC and MAC, they are the data link protocols. And the bridge operates as we have described just in the previous slide. MAC frame whose destination is not on the immediate LAN or not on the same LAN will be captured by the bridge. It will be buffered and then transmitted on the another LAN. So for example, if a station wants to send a data to the station number 20, so this frame will be captured by the bridge. It will be buffered and then it will be transmitted on the another LAN, which is LAN B. So the LLC layer, which is another protocol of the data link layer, there is a dialogue between peer LLC entities, and the bridge need not to contain on LLC layer because it is serving on the MAC frame. So this is how the communication is done. Alright, now here we have an example of the bridges with the LANs and the alternative routes over here. So if you see, I have many bridges. I have how many LANs? LAN A, LAN B, LAN C, LAN D, E, F and G, and there are 1, 2, 3, 4, 5, 6, 7 bridges. So if you see, LAN 101, bridge 101 is connecting LAN A and LAN B. Then bridge 107 is connecting LAN A and LAN E. Bridge 102 is connecting LAN A and LAN C. Similarly, bridge 103 is connecting LAN B and LAN D. Bridge 104 connecting LAN B and LAN E, and so on. Okay, so let's just talk about an example how the stations are going to transmit by using the bridges. Alright, so we have a simple configuration. Multiple LANs are connected to each other with the help of the bridge in this case. Now let's assume that station 1 wants to transmit a frame to station 6. Station 1 is on LAN A and station 6 is on LAN F. So it wants to transmit a frame to station 6. Now, when it wants to transmit to the station 6, the frame will be first of all read by bridge 101, 107 and 102 because LAN A is connected to all these bridges. Now for each bridge, the address station is not on a LAN to which bridge is attached. If you see, the attached station is neither on bridge 101 is attached to LAN B. Station 6 is not there. Bridge 107 is attached to LAN E. Station 6 is not there. Bridge 102 is attached to LAN C and station 6 is not there. So now each bridge must make a decision whether or not to retransmit the frame on its LAN in order to move it closer to the intended destination. So in this case, bridge 102 should repeat the frame on LAN C. So bridge 102 needs to repeat the frame, send the frame on LAN C. Whereas bridge 101 and 107 should not retransmit the frame. Now once the frame has reached to LAN C, it will be picked up by both the bridges 105 and 106. Now again, each of these bridges must decide whether to forward the frame or to not. So in this case, bridge 105 should retransmit the frame on LAN F, where it will be received by station number 6, whereas bridge number 106 should not transmit the frame. So we can see from here that bridges should be equipped with a routing capability. That means Bridges must learn the path, bridges must learn the route. So when a bridge receives a frame, it should decide whether or not to forward it. When I say that bridge 101 and 107 should not send, how they should decide that they should not send? That means they must have some routing capability, or they must have some routing decision or routing table. So if the bridge is attached to 2 or more networks, then it must decide whether or not to forward the frame, and if it wants to transmit, on which LAN the frame should be transmitted. So on which LAN it should be transmitted. The bridges must have some routing decision or routing capability. But this routing decision which we are talking about, it may not be always as simple as it looks like. Now in this figure, if you see, there are between LAN and LAN A and LAN E, there are 2 routes. The first route is from bridge 101, LAN B, then bridge 104, and then LAN E. Another route is from bridge 107 and directly to LAN E. So there are 2 routes between LAN E. Such duplication provides for higher overall internet availability, and it creates a possibility for load balancing. So in this case, if station 1 wants to transmit a frame intended for station 5 on LAN E, so station 1, which is on LAN A, wants to transmit to a frame to a station 5 which is on LAN E, then either bridge 101 or bridge 107 can forward the frame. It should appear preferably bridge 107, because bridge 7 is directly attached to the LAN E, since it will involve only one hop, whereas the frame travels through, because if 101 wants to transmit, then it will go to the LAN B, then from LAN B it will go to the LAN bridge 104. That means it has 2 hops. Another consideration is that there may be changes in the configuration. For example, bridge 107 may fail. What happens if bridge 107 fails? So in that case, subsequent frames, all the frames from station 1 to 5, it should go to bridge 101 and then to bridge 104. So we can say that routing capability must be taken into account the topology of the internet configuration, and it may need to be dynamically altered. So this is all about for today's lecture, and we are going to talk about more about routing, what type of routing algorithms or routing type decisions a bridge can have in the next lecture. So thank you so much.